Hi Teffo, I hope you're doing well and welcome back. Right, so yesterday we were looking at factorizing trinomials where our a value was equals to 1, right? So now today what we're going to do is we're going to move on to looking at factorizing trinomials with a greater than 1, right? So now you can see that our a in both of these trinomials, right, has a coefficient which is not 1. Right? Over here it's 4 and over here it's 5. Right? Notice that this is still trinomials, right? You don't always have to have an x over here, right? You can have any variable, right? In this first one, we have a variable a, and the second one we have a variable y, right? Still same procedure, right? So the instruction is to factorize fully again. The approach that we're going to take in order to factorize these type of trinomials is exactly the same as yesterday, right? We're still going to factorize them by inspection, right? And this time there's just one extra step that you have to add, and that is to always check if there is a common factor that you can pull out from all of the terms, right? That's actually the first thing that you must always check when you're factorizing, right? The first easiest thing that you can do is to pull out a common factor, right? So you can see over here in example number 1, right, we can pull out a common factor of 4, right? And if we do that, that's going to make the trinomial that's left over to be much easier to factorize compared to trying to factorize 4a squared plus 12a minus 40, right? Now, in the second example, unfortunately, there is no common factor that we can pull out, right? So we're going to have to look at how are we going to approach the second example, right? So let's start off with this first one, right? So we have a common factor of 4, so we're going to pull that out. So we're going to write equals, right? We're going to pull out the 4, and that's going to leave us with an a squared plus 3a minus 10 inside of a bracket, right? Now, obviously, we need to factorize this trinomial further. Okay, so we're going to have 4, right? And realize that this is the same as what we were doing yesterday, right? Where our a term is equals to 1. So we can just use the same method that we looked at yesterday, right? Open two brackets, just put an a and an a, right? And then now we need to look at the factors of 10, right? And that's going to be 1 times 10, 2 times 5, and 5 times 2, right? So that's the end of it. Okay. So now if we just scan this quickly, right, you can see that obviously 1 and 10 won't get you to a 3 very quickly. So we can just cancel this out, right? But we can use 5 and 2 to make a 3, right? How are we going to use that? Well, we can have 5a, right? So we're going to put a 5 over here. And then from that 5a, we can subtract out 2 of the 8s, right? So subtract 2a, and that's going to give us your 3a. Then the last thing we need to check is that this sign over here is also accounted for, right? And it is because negative times positive is a negative, right? So that is now that trinomial fully factorized. Okay. For the second example, right, like I said, there is no common factor that we're going to have to pull out over here. So unfortunately, what we're going to have to do is we're going to look at the factors of 5, right? And luckily for us, 5 is a prime number, right? So this just factorizes nicely into 1 times 5 and nothing else, right? And the factors of 8 we saw yesterday is 1 times 8 and 2 times 4. Okay. Now, our next step is to open two brackets like usual, right? But now inside of this bracket, we're not just going to put a y and a y, but you can start off like that. It's fine. I'm going to put a y and a y. Okay, and notice that I'm leaving a space in front of my y's this time, and that's because we have to put something in front of those y's, because now our coefficient a is greater than 1. Okay, so it's not the same as over here, right? Okay, so what's going to go in front of these two y's? Well, the factors of 5. Okay, it doesn't really matter which one you put where, just put them. Okay, so 1 will go there, and 5 can go here. Okay, so now we're going to move on to the next step. Right, the next step is to consider each of these two multiplications, right, each of these products separately, right? So we're going to start with the top one. Okay, and what we're going to do is we're going to say, okay, we have a y, right? So y times 1 gives us a y, right? Hold on to that result. Okay, then we have 5y times 8, okay, that's going to give us a 40y, okay, so we have 40y and we have a y, okay, 40 and 1y won't get us to 14y very quickly, right, so we can just immediately say that we can't use this factor, okay. Now let's check 4 and 2, okay, we'll start again. Y times 2, okay, is 2y, hold on to that, okay. 5y times 4, okay, is 20y, right. Now we have 20y and 2y, so that will give us an 18y, right. We are looking for 14y, okay. So let's try to reverse the order, okay. What if we look at 5y times 2, right? So that will give us a 10y. Hold on to that. So we have a 10y. And then y times 4 is a 4y. So we have 10y and 4y, and 10 plus 4 is 14. Okay. So which means that inside of this bracket, right, we have to have 5y, okay, times 2. Okay, so we're sort of like working backwards now, right? So 5y times a positive 2, okay, will give us our required 10y, and this y times a positive 4, okay, that will give us our 4y, okay? 4y plus 10y is 14y, okay? Now lastly, for the sign, well, it's a positive, so positive times positive is positive, so the sign is also okay, right? Now, by convention, we obviously don't write this 1 over here, okay, in front of this y, right? So we can just rewrite this as just y plus 2 times 5y plus 4. Right, so that's that trinomial fully factorized. There we go. Okay, so now on to our challenge question, right? For the challenge question, we are asked to solve the equation, right? And these are the type of questions that you're going to see more often in your past papers and tests and things like that. Okay. So what we've been doing so far is we've been practicing the skill, right, of factorizing. Okay. So now I'm going to tell you now that this equation over here is going to transform itself into a trinomial, right? It has a trinomial embedded inside of it, okay? And that trinomial is going to come out when we are trying to solve for this x, okay? Because that's the instruction, right? So the instruction before was to factorize, but now the instruction is to solve the equation, okay? And whenever we are asked to solve the equation, what they want us to do is to find the value of x, right? Such that if we plug this value of x back into this left-hand side and this right-hand side, okay, we get the same answer, right? Now, if you look at the way that our equation is set out now, like currently the way that it's set out, on the right-hand side, we have the square root of an unknown, right? Now, we have to make sure that whatever x value that we get, when we plug it back in here, we don't get a negative underneath the square root, right? So you have to know that at this level of maths, right, the square root of a negative number, right, is undefined, okay? So this is the equation that we need to solve for x, right? Now, what we're going to do is we're going to use inverse operations to help us to solve for x. Okay, so now the easiest thing to do is to cancel out the square root. Right. Now the inverse operation of square rooting is to square. Right. So what we're going to do is we're going to square both sides. Now notice that I'm using brackets, okay, because we have to square everything right on the left hand side and everything on the right hand side. Okay, now this square root and the square cancels each other out, leading us to our next step, right, where we have to FOIL out this binomial squared. Okay, so we'll write it out for now. It's a 5x plus 3, okay, and 5x plus 3. Right, and this is equals to 3x plus 7. Right, so now we have to FOIL these two brackets out. So which means that we have to basically go 5x times 5x, right, which will give us 25x squared. And then we need 5x times positive 3, which is a positive 15x. Then we need positive 3 times 5x, which is also positive 15x. And then we need positive 3 times positive 3, which is a positive 9. Okay, and this is equals to 3x plus 7. Right, now you can see that we've already set out a trinomial for ourselves. We just need to clean it up, right? And the way that we're going to clean it up is to combine all of these like terms, right? 15x and 15x. I don't know why it highlights like that, but anyway. So 15x and 15x and 3x, right? Those are like terms, right? And this 9 and this 7, those are also like terms. Okay. So what we're going to do is we're going to move this 3x and the 7 to the left hand side so that we have 0 on one side. Okay. So whenever you have a trinomial that's being set up in an equation, right, in order to solve for it, we have to have 0 on the one side. Okay. So we'll have 25x squared, right, plus 15x plus 15x, right? And we're going to bring its friend over, which is this 3x, but now it's going to become a minus 3x, right? And we have that plus 9. Bring its friend over, which is the 7, and it becomes a minus 7. And that equals to 0. Okay, so now simplifying this, we'll have 25x squared, right? And then 15x plus 15x is 30x, minus 3x is a positive 27x, right? And then 9 minus 7 is just plus 2, and that is equal 0, right? So now, Teffo, this brings us back to what we were really trying to concentrate on today, right? This is why this was considered a challenge question, right? Because the task that we were practicing today, which is to factorize trinomials with an a value greater than 1, right? That task is embedded inside of this solving for x question, right? So let's see how we're going to factorize this. Well, if we look at the factors of 2, right, that's going to be, let's write it on the side over here, 25x squared plus 27x plus 2, right, is equals to 0, right? But then I didn't actually want to write this equals to 0. Okay. Just want to keep it as a trinomial like we are used to, right? Now 2 is a prime number, right? So the factors of 2 is only 1 and 2, okay? And for 25, we can look at 1 and 25. Okay, we can look at 5 and 5. We can also look at 25 and 1. Okay. Alright, so now let's see. Okay, so if we open two brackets, right, we open two brackets. Okay, let's consider this first one. Okay, if we have a x over here and a 25x over here, right, then we'll have x times x, right, and then we'll have 25 times 2, which will give us 50. We are trying to get to 27. Okay, let's see if we work the other way around. If the x multiplies with the 2, okay, then we'll have x times 2. That's 2x. The 25 multiplied with the 1 is going to be a 25x, right? Now, 25x and 2x can work to give you a 27x because 25 plus 2 is 27. Okay, so we're not going to use this. We're going to be using this, right? So in our first bracket, we can write down an x. In our second bracket, we can write down a 25x, right? Remember that that x has that coefficient of 1, right? Now, we said that we will need a 2x, right? So we can put the 2 over here, right? So there is our 2x, right? And then we need a 25x, right? So we're going to put this 1 over here, so plus 1 over here. Okay, so we have our 2x plus our 25x gives us our 27x. Signs, positive times positive is a positive. 1 times 2 is 2. Okay, so that is the factorization of this trinomial. So now you take this, right? You take this result and you're going to put it over here. Okay, so that is going to be x plus 1 and 25x plus 2. Right, this is now no longer just a trinomial, right? We're not just factorizing, okay? We are now solving an equation, so we still have this equals to 0. Okay. Now, the reason why when you are solving trinomials, you have to equate it to 0 is because you can now apply, right, the property that says that if you have a product, okay, so A times B, and that product is equals to 0, right? This is true if and only if, right? So if and only if, right? A is equals to 0, B is equals to 0, or A and B is equals to 0, right? So it's either A is equals to 0, because 0 times whatever this value is will be 0, or B is equals to 0, right? Or both of them are equal to 0, right? We're not really that much concerned about the both of them being equals to 0. What we are concerned about is this, right? And this part is what we use to solve this equation, right? So essentially what we're going to do is we're going to say, well, this is true, right? When the first bracket x plus 1 is equals to 0, or when the second bracket 25x plus 2 is equals to 0, right? Now you've set up two individual equations, right? Small linear equations to solve for yourself, right? For this first one, it's very easy, right? To solve for x, you just need to subtract 1 from both sides. So then you'll have x is equals to negative 1, right? For this one, we have two steps. So we have 25x, right? That's going to be equals to negative 2, right? And then the next step is to divide both sides by this 25 to get this x value, or x variable, sorry, alone, right? So we're going to have x is equals to negative 2 over 25. Okay, Now, remember that when we started off with this, right, we just had a 5x plus 3 is equals to the square root of 3x plus 7. Okay, so now we need to test both of these x values to see that they don't give us a negative underneath the square root, right? So if we look at 3, right, so we're looking at when x is equals to minus 1, right? So 3 times minus 1 plus 7, okay, that's going to be equals to negative 3 plus a 7, which is a 4. Okay, so minus 1 is fine. Okay, now let's look at when x is equals to minus 2 over 25. Okay, so we're going to have 3 and our x is a minus 2 over 25, right? And we need to add 7 to that, right? Now we can see that this will simplify to negative 6 over 25, right? And we need to add that to 7. This is definitely not going to be a negative number because we're going to have to multiply top and bottom by 25. 25 times 7 is something much greater than minus 6. So this is also greater than 0, right? So this x value is also fine. Right, so now the last thing you'd have to do is to check that when you substitute both of these x values, you get the same answer for the left-hand side and the right-hand side, right? So you're going to plug it into this initial equation individually, right? And when you do that in your calculator, you'll see that n is equals to minus 1 is not a valid solution. So what we do is we're going to write NA in front of n is equals to minus 1, right? And that finalizes our solution. So our only valid x value that makes this equation true, right? In other words, it makes the right-hand side equals to the left-hand side is an x value of minus 2 divided by 25. Right, so now you can try, right? You have two examples over here. You need to factorize fully, right? And your a value is greater than 1. Okay, so let's go through it. Right. Hopefully you were able to see that for this first one, there's a common factor of 2 that we can pull out. Right, so this is equals to 2 times x squared minus 7x minus 18. Okay, and then now you just need to factorize the quadratic. So we have 2 on the outside. We'll open our two brackets. Okay, in the one bracket we'll put an x, and the other one we'll also put an x, right? They both have a coefficient of 1, right? Now for the factors of 18, well, we have 1 times 18. If you divide it by 2, you have 2 times 9. You can't divide this by 3, but you can actually, sorry. So 3 times 6, and then you have 6 times 3. Okay. Right, so out of these three factors, we can see that in order to get to a 7, right, we are obviously going to have to use this 9 and the 2. Okay, so then we need a minus 7, right? So we can have a minus 9 and a positive 2. That will give us a minus 7, right? So this x times a negative 9, right, and a positive 2. Okay, what about the signs? Well, positive times negative is negative, so the signs are also accounted for, right? And there you go. If you got this correct, well done. Okay, for the second example, right? In the second example, we have the case where you can't pull out a common factor from any of the terms, right? So you have to then go through the process of factorizing. But this one that I gave you was quite easy, right? Because 1 is a prime, or not a prime number, but 1 only has 1 times 1 as its factors, right? And 3 is a prime number, and it has factors 1 times 3. Okay, so this factorized very easy, right? You know that in the one bracket you have x, in the other bracket you have 3x. Okay, so now you can check, right? 1 x times 1 is 1x, and 3 times 1 is 3x. Okay, so you have an x and you have a 3x, right? But you need a minus 4, so which means that you need a minus x and a minus 3x to give you this minus 4x. So which means that this x needs to be multiplied by a negative 1, and this 3x needs to be multiplied by a negative 1. Okay. Then the signs will be accounted for because negative times negative is this positive, and 1 times 1 is 1. Right, and there you go. If you got this one right as well, well done. Okay, so this brings us to the end of factorizing trinomials with a being greater than 1.